inverse trig functions. So now we get to finally use a button on our calculator that we've been itching to use for a while. So first of all, we need to define the inverse sine function. The inverse sine function is the angle whose sine is something. Okay, so the angle whose sine is 1/2, you would say is what angle? What angle has a sine that's ratio is 1/2? 30 degrees. Okay, the angle whose sine is 1/2 would be 30 degrees. The angle whose sine is the square root of 2/2 would be 45. So we're working our way backwards now. Okay, we have the answer. We're trying to figure out what angle caused that answer with that particular trig function. Okay, so for us to be able to talk about the inverse sine function, for it to be a function, it has to pass the one-to-one test. In other words, it has to pass that horizontal line test. Now we know that sine waves oscillate over and over and over again forever, right? So we have lots of places where it would not pass the horizontal line test unless we restrict the domain of the sine, or the inverse sine. So we need the full effect from -1 to 1. So we restrict the domain of the inverse sine function to be between -π/2 and π/2. So far, so good? Between -π/2 and π/2 is the portion that we're going to talk about being the inverse sine, because that gets us some positive values and it gets us some negative values. So far, so good? Okay. The way that we're going to denote it, there's two ways. Some books use arcsine, which means the angle whose sine is, and some of them use the inverse sine notation. Sine to the negative, it looks like it's to the -1 power. It's not. It's the inverse sine. Tell me which angle has this sign. Okay? Tell me which angle has this opposite over this hypotenuse. Okay? So both of them will be used interchangeably. So when we want to evaluate the inverse sine function, we're asking, hey, which angle has a sine that has a ratio of 1/2? And you already told me, right? 30 degrees. Okay? So we're used to saying it in degrees. What would that be in radians? π/6. So you could give it to me either way. Okay? Tell me which angle has a sine that has a ratio of square root of 3/2. 60 degrees. And what is that as a radian measure? Yep, 60 degrees π/3. Okay? Tell me which angle has a ratio of square root of 3 for the sine. So tangent has a square root of 3 at 60, right? The sine of 45 is square root of 2/2, right? The only time we see a square root of 3, not a square root of 3/2, is with the tangent, right? Now let's think about this. Is this even possible? What is the square root of 3 roughly? 1 point something, right? Okay, probably closer to 2 than it is to 1, because the square root of 4 is 2. The square root of 1 is 1. So we're closer to 1 point, no, to 2 than 1. Is it possible to have an angle who has a sine that's more than 1? No, because sine's restricted, right? The biggest it can become is 1, and the smallest it can become is -1. It oscillates between 1 and -1, unless we've made a change to its parent function. So this one is not possible. Okay, so far so good? Questions on this one? Okay, so if we are graphing the arcsine, we're graphing the inverse sine, then remember that this is the inverse of the sine. When we graph y equals the sine of x, we plug in values for x and see what it is for y. So we typically plug in things like π/2 and pi and 3π/2 and 2 pi. And where does the sine start? What is the sine of 0? 0, right? So at 0, the sine of 0 is 0, the y is 0. At pi over 2, the sine of pi over 2 is 1, right? And then at pi, we're at 0, and at 3 pi over 2, we're at a negative 1, and at 2 pi, we're at 0 again. So we've got a nice sine wave going on here, right? Okay, so that's when we have values that we're plugging in for x and figuring out what y is. The inverse says, let's flip them. Okay, when you want the inverse of a function, you let the x be the sine of y. And how do we solve that? We're going to solve for y, so we have to do the inverse of the sine. Okay, so when we take the arcsine of x and the arcsine of y, we get y equals the arcsine of x. So because we switched our x and our y around, that means that we're going to switch our x and y around in our table. Okay? Now we said that we're only defining this between negative pi over 2 and pi over 2, so it can be a function. So it can be 1 to 1, pass the horizontal line test. So do you remember what the square root of 2 over 2 was as a decimal? When we graphed it the very first time? 0.7, okay? So this is roughly, approximately a negative 0.7, and this is approximately a 0.7. So let's think about what this is going to look like now. Now my x is going to be a negative 1 and a negative 0.7 and a negative 0.5 and a 0, right? So we'll have a negative 1, negative 0.5, here's my 0, here's my 0.5, and here's my 1. And my y is going to be the negative pi over 2, the negative pi over 4, the negative pi over 6, and so on, right? So when x is a negative 1, y is going to be down here at a negative pi over 2. Yep. It's tiny. I didn't have a lot of room. Okay. All right, so here we go. So when we were at negative 1 for x, the y is that negative 1.2, or pi over 2. And when y is a negative pi over 4, we're at that negative 0.7. And when y is a x is a negative half, y is a negative pi over 6. And when x is 0, y is 0. When x is 1/2, y is pi over 6. When x is 0.7, y is pi over 4. And when x is 1, y is pi over 2. It looks like a line, but it's going to have this inflection going on. Okay? It's a reflection of this piece, okay, across the line y equals x. So it's a reflection of this portion of the graph across the line y equals x. Okay? Everyone see that? The green is that. So we're going to be graphing the arcsine, the arccosine, and the arctangent, and understanding what those mean. Okay? What angle has this sine? What angle has this for the cosine? What angle has this ratio for the cosine? Questions on this one? Okay. So our next slide says we have other inverse trig functions. One of them is the cosine. Okay? The arc cosine says, guess what? We can't say, let's restrict this guy from negative pi over 2 to pi over 2 like we did with sine, because then it wouldn't pass the horizontal line test, right? So we're going to restrict the domain of the arc cosine to be between negative 1, or the domain of the range of the arc cosine to be between negative 1 and pi. Or sorry, 0 and pi. Okay? That way we get one portion of that cosine wave that isn't repeated. So this is like saying, hey, guess what? We need to be in the first quadrant and the second quadrant, because cosine's negative here but positive here. We get both of them. So we're between 0 and 180 degrees, 0 and pi. Whereas the sine had to be in the first and fourth quadrants, because that way the sine could be negative and also positive. That's why it's between negative pi over 2 and pi over 2. Okay? Where do you think we're going to put the tangent? Where will we restrict the tangent? No guesses? Tangent's going to be the same as the sine, right? Cosine gets to be the anomaly again. It's the even one, it's the even function, and it's also the one that's going to be restricted. The arc cosine will be restricted between 0 and pi, and the sine and tangent will be between negative pi over 2 and pi over 2. Okay, so far so good? All right, so cosine has an inverse on this interval, and these are things that you don't have to copy down because they're in your book. Tangent's also going to have an inverse between negative pi over 2 and pi over 2. Okay? Again, the domain for the arc cosine is between negative 1 and 1, but the domain for the tangent is going to be negative infinity to, for the arc tangent, it's going to be negative infinity to infinity, because what happens to the range of the tangent when we approach those asymptotes? It gets to go to positive and negative infinity, doesn't it? So these are just flipped from what you saw originally. Okay? And again, this is in your book. You don't have to write it down. Okay? So far, so good? All right. So here we go. This is what the arc cosine looks like. Okay? Nothing more than a reflection of this portion of the cosine across the line y equals x. Okay? And then the tangent, the arc tangent is going to look like this. And understand that the domain can go on and on and on forever, right? Because it's going to approach those asymptotes, but it can be any value for x, positive or negative. But it's restricted between negative pi over 2 and pi over 2 for the range. Okay? All right. So, let's apply it. If possible, we want to find the exact value for the angle whose cosine is the square root of 3 over 2. Inverse cosine, arc cosine. So square root of 3 over 2, what angle gives us that ratio for the, that's a third, for the cosine? Sine of 30 is the half. Sine of 60 is the square root of 3 over 2. So cosine and sine are cofunctions, right? The cosine of 30 is the same as the sine of 60. So this is going to be 30 degrees. Okay? So this is a 30-degree angle. What's that in radians? Yep, pi over 6. What angle has a cosine of negative 0.5? Negative 1/2. So what's the reference angle? Where's cosine 1/2? 60, okay? The cosine of 60 is a half, right? Now, we've restricted the cosine to be in which two quadrants? The arc cosine, I'm sorry. Yep, in these two, right? Between 0 and pi. So this is where the cosine is going to be negative, right? What's a 60-degree angle? Always to the x-axis. What's a 60-degree angle in the second quadrant? 120. 180 minus 60 is 120. So this is a 120-degree angle. What is it in radians? 2 pi over 3. Okay, so far so good? Okay, you see why we want you to have these things down and memorize and know them at the back of your hand? Okay, all right. So, which angle has a tangent that has a ratio of square root of 3 over 3? Where's the tangent square root of 3 over 3? 30 degrees, a 30-degree angle. Okay, it's not negative, so we get to be in that first quadrant, 30 degrees, and that, what is that in radians? Yep. And where is the tangent 1? Where the sine and cosine are square root of 2 over 2, which is 45. What's 45 in radians? Pi over 4. When we ask you for an exact value, that means that we have those primary angles, those reference angles, like the special angles, the sine, cosine, tangent of 30, 45, 60, 90s, 180s, 270s, right, and zeros that you're supposed to know. Any questions on this one? All right, let's keep moving. So now we're going to use a calculator to approximate. Okay, so let's pull out our calculators. Some kind of scientific or graphing, it doesn't matter. Good question. Okay, so do we want to be in degrees or radians? It doesn't matter in this case, right? We're going to find an angle whose tangent is 1.9. But if we're in radians, it's going to give us an answer in radians. If we're in degrees, it's going to give us an answer in degrees. Which one are you more comfortable and familiar with? Degrees. So it probably makes sense to have it in degrees so that you can ask yourself if that even makes sense, right? So let's change our mode, if it's not already, to degrees. So you want to make sure that that degree is highlighted or darkened, shaded. And then we want the angle whose tangent is 1.9. Okay, that's the same thing as the arctangent, a tangent with, like, as if it's raised to a negative 1 power, but it's the inverse. So where's your inverse tangent button at? Yep, it's the second of your tangent. Okay, so second of tangent. I did turn it to degrees because we're more comfortable with degrees, right? But if they ask for it in radians, you'll need to have it in radian mode. So second tan, inverse tangent of 1.9. So this is going to tell us what angle has a ratio of 1.9 for its opposite over its adjacent. And that will tell us that it is a 62.24 degree angle. Everybody get that? Okay, so 62.24. And we can multiply it by pi over 180 to get it in radians, or switch our calculator back to radian mode to get it in radians. Okay, next one. Which angle has a cosine of a negative pi over 3? So they're trying to mess with you, aren't they? Okay, they're saying the angle whose cosine is a negative pi over 3. What happens when you plug it in your calculator? And you have an error in domain, right? It's undefined. It's not possible. Why is that not possible? When we take pi, what is pi as a decimal, roughly? 3.14 divided by 3 is a little bit more than 1, right? Can we have an angle who has a cosine that's more than 1? No. So this is not even possible. They're just trying to mess with your mind and see if you'll bite on it. Okay? So this is undefined. So it's not the cosine of negative pi over 3, right? It was asking for the angle whose cosine was negative pi over 3. So this is not going to be possible. Okay? All right, next one. We want the angle whose sine is negative 0.919. So second sine, and is it possible to have a negative? You bet. Make sure you use your negative not your minus sign. So an angle whose sine is a negative 0.919. Everybody get a negative 66.78 degrees? Okay, and that's how you can leave your answer. You can leave that answer in that form because we have defined it between negative pi over 2 and pi over 2, right? And of course, you could also keep that in radians as well. Questions on these? Okay, all right. So, inverse properties of trig functions. We can compose these guys, okay? We can use them to undo themselves. Log, yes, the log and the exponent, exactly. Logs and exponents are inverses of each other. Squares and square roots are inverses of each other, right? So if we want to undo a squared term, we take the square root, and those two pop away, and you're left with whatever was underneath the radical. Same idea here, okay? So the sine of the arcsine of x will be x, and the arcsine of the sine of y will be y, okay? And likewise, the cosine of the arccosine of x will be x, and the arccosine of the cosine of y will be y. Okay? And same thing with the tangent. So you don't have to write this down. It's in your book. You can look it up if you need to. Okay? I want you to spend time just writing to be writing, but sometimes writing helps you remember. Okay? Just a little bit short on time today because of the schedules. So, if possible, find the exact value. Okay? We want to know what the tangent of the arctangent of 23 is. It is 23. Okay? Can we find an angle whose tangent has a measure of 23? Absolutely. Tangent goes on forever, right? So what angle would that be? Well, we don't know, but the tangent of that angle would be 23. Okay? So the tangent of the arctangent of 23 is simply 23. Okay? The sine of the arcsine of pi. We think it might be pi. Okay, but ask ourselves, is there an angle whose sine is 3.14, roughly? If you don't think so, check on the calculator, see if you get an error in the domain. The arcsine of pi, is that possible? No. So don't let them trip you up and just make you write things down, right? You have to use your brain. So arcsine of pi is not possible, so we can't take the sine of something that's not possible. So this one's not possible. Okay? What about the cosine of the arc cosine of a negative 0.82? Can we take an arc cosine of a negative point something? Absolutely. Okay? When we find the angle that has that, we'll take the cosine of that angle and, yeah, negative 0.82. They just drop away. Okay? It's like taking the square of a square root or the square root of a square. Okay? But it has to be possible in the first place. Does that make sense? Okay? All right. So today, we want to do one last thing and then turn you over to your assignment. Sometimes we like to mess with you a little bit and say, hey, tell me the value of the sine of the arc cosine of 2/3. So first of all, do we know, and this is the exact value, so I don't want a decimal. I want something in radicals, with radicals in it. But do we know the arc cosine of 2/3 off the top of our head? Is that one of our special angles? No. So let's think about what this means in terms of a right triangle. Back to our right triangle trig. If this is theta and this is the arc cosine, what did the cosine stand for in SOHCAHTOA? Adjacent over hypotenuse. So here's our adjacent, that's the 2. The hypotenuse is the 3. So if we want to find the sine, we need to have the opposite. So it's going to be the square root of 5 because the 9 is equal to 4 plus b squared, right? So this will be the square root of 5. Everyone see where Ray got that? Okay. So now, what is the sine of this theta? Square root of 5 over 3. That's the answer. Okay, as long as you remember your right triangle trig, you're in good shape. So we're now finally bringing you back. We've done some graphing of not only the sine, cosine, and tangent, but also the secant, cosecant, and cotangent, and the parent functions, reverting them back to the parent functions and changing. And now we want to make sure that we go back to this stuff and make sure we remember everything that we've done this chapter. Okay, and this is part of that. All right, your assignment's not that long because it's going to be quick stuff. Page 326, 1 through 26.